Hi, welcome to our first video for 6.6 Arithmetic Series. So in this lesson, we're going to learn how to calculate the sum or the total of an arithmetic sequence. So remember, arithmetic sequences, they have the pattern where they always have a common difference between the consecutive terms. So the explicit formula is given by the first term plus the common difference times n minus 1. So this formula is used to calculate any term that we might look for in the arithmetic sequence. So in order to be arithmetic, remember, it has to have a common difference. Okay, D is the common difference between each consecutive term. So what we're looking at today is how can we find the sum of all these numbers? Okay, that's what we'll get to shortly. So first we're going to do a quick little activity, something that Gauss is that famous mathematician. You might have wrote some of his contests in the past. Gauss, when he was about the age of 8, he kind of astonished his teacher by almost instantly determining the sum of the natural numbers from 1 to 100. So like 1, 2, 3, no decimals, all the way up until 100. He found the sum of all of those. So I'm going to ask you to try and find the sum right now. You can go ahead and pause the video and try to come up with a technique or a method for you to find the total of all those numbers. Okay, welcome back. I'm curious to see what you guys would have came up with and maybe some of the approaches that you would have taken. So I'll kind of show you what Gauss did. So mentally, he thought about the numbers from 1 to 100, and I'm not going to write them all out. We'll go 98, 99, 100. So he thought about them in ascending order, and then he thought about them in the reverse order. Okay, so now they're going down all the way to 3, 2, and then finally to 1. So they're both the same set. They're just written out. One's written out in the reverse order. So it's actually easier to add these all up together than it is to just add these up on the top. Okay, and there's a good reason for that. So if you look at these numbers, there's actually something special about this. So if you look at this first pair, this second pair, and the third pair, okay, they all add up to 101. Okay, so let's highlight this again, a different color. That adds up to 101. And same with this one, and same with this one. And all the way as we get towards the end. 98 and 3, also 101. Okay, you guys get the idea. So what happens is we know there is 100 of these because it's the natural numbers from 1 to 100. So there's 100 terms. So we're going to have, we'll write the sum here. The sum is equal to 100 terms times 101. Okay, so what we're doing is we're finding the total of all of these, okay, which will be really easy. We can just move the decimal place over twice to get 10,100. And now we just need to cut this number in half, because remember, this is for the total of all of these, so one set is going to just be half of that. So we have to divide this by 2, and we're going to get 5,050. So Gauss didn't write this out using pencil and paper, but he thought about these numbers and he paired them up. And he came up with that one quite quickly. So this is actually the technique that we're going to use to find the sum of arithmetic series. So, and whenever we use the word series in this chapter or in any math context, the series refers to the sum. It means the total of all the terms in the sequence. So we're now going to derive this formula that Gauss basically used, and we'll see how it can work for any arithmetic series. So we're going to use the symbol Sn to represent the sum of the series. Okay, so this means the sum of the series. So for an arithmetic series, My first term is always a, and then my next term is going to be a plus d, because remember it's an arithmetic sequence, so we always add d to get the next term like we did up here. So the first one's a plus d, the next one's going to be a plus 2d, because we would add d twice at that time. And this is going to go all the way up until we get close to the last term. So my second last term, remember Tn represents some term number at the end of our sequence. So the second last number, we're going to have Tn minus d, because it's going to be one common difference less. And the very last term is T of n. So this is the last term. This is second last term. Okay, and these all represent the terms in the sequence. It doesn't matter what they start at. It doesn't matter what the common difference is. They're all going to follow this form. So to get the sum, we need to add all these up. So if we take Gauss's approach, and if we add a whole nother set of this again, but we're going to put this in the reverse order. So starting from the last term, and then we have the second last term, and then the third last term. So this one we'd have to take away two d's. Okay, you guys get the idea. And then the second term would be a plus d, and the first term is a. So this is the reverse order now, right? I'm just going to change colors here. So this is last term. Okay, second last term. Okay, you guys get the idea. This is second term, and that's the first term, right? So if we add all these up together, so I'm going to add everything up, all of these, we see something special happen. So at first, Sn plus Sn is going to be 2Sn. That's everything on the left side. And now here we have the first and last term. So that adds up to a plus t of n. Okay, notice that they actually all of these add up to a plus t of n. So when I add these here, d minus d cancels out, and I'm left with just a plus t of n. So when I take this plus this, the d's cancel, and I have a plus t of n, just like I have right here. It also happens again here. The 2d cancels out with the negative 2d, and I'm left with a plus t of n again. And then same with here, negative d plus d cancels, and then this last one is also a plus t of n. So there's actually going to be a plus t of n times the number of terms here. How many terms are there? Well, n. There's going to be n number of terms. So 2 of n is equal to n, which is the number of terms. And then we have a plus t of n. So the a plus t of n is the value of each one of these all the way through, and there's n number of them. So when I do this, I'm actually finding the value of both sums, so it's 2Sn. So now to find the sum, I got to cut it in half. So we'd have Sn equals n over 2 times a plus t of n. So this is our formula that we just derived. We can use this for any arithmetic sequence. Remember, a is the first term. A is the first term. T of n represents the nth term, so the last term in the sequence. And n is the number of terms. So to use this formula, we need to know the first term, we need to know the last term, and we need to know the total number of terms. Okay, the cool thing is because this is an arithmetic sequence or an arithmetic series, we can actually add a little more information here and come up with a second formula. So remember, I'm going to write that up here to say recall. Okay, T of n is equal to A plus D of n minus 1. So I could actually use that and I can plug that in here for T of n. And now I have this formula for calculating the sum, not just in terms of A and Tn, but also D and n minus 1 as well. So that's what we're going to do here. We're going to sub Tn equal to A plus D times n minus 1 into, I'm going to call this equation 1 here, just to keep it simplified here, into equation 1. So we're going to have Sn equals n over 2 times A plus, and here's the substitution, we're going to have A plus D times n minus 1. Close up the brackets. Okay, I can collect the like terms, and I can also distribute if I need to, but I don't think we'll need to do that. So we'll write n over 2. So we have this plus this bracket. Well, I can drop the brackets because we're just adding the terms. And A plus A is going to be 2A. Just by adding those together. Okay, and this is our second formula that we can use to find the sum of an arithmetic sequence. So I'll call that number 2. Okay, so that's it for our introduction for finding the sum of an arithmetic series. Now, I'm not going to ask you to derive these formulas for the test, but you do need to know how to use them, okay? So these two formulas are a staple for finding the sum of an arithmetic series. Okay, let's go ahead and do our first example. So it says, determine the sum of arithmetic series. Determine the sum of the first 10 terms of each arithmetic series. So let's start with part A. So we're told A equals 2, D equals 4, and there's 10 terms, and the last term is 38. So we're looking for the sum. Okay, I can then look at my equations, and I have A, D, and the 10th term. So this is my last term. So I know I could just use this formula here. Okay. I also know that if there's 10 terms, I know that n needs to equal 10. So I actually have n, I have A, and I have the last term. So this is kind of everything I need. I don't really need this value of D at all. So we're going to apply the equation. So 10 terms, we're going to have 10 over 2. The first term is 2. The last term is 38. So we have 5 times 40, 200. So that would be the sum of the arithmetic series from 2 all the way up to 38 with a difference of 4. So that sequence would look like this. It would be 2, 6, 10, and it would go all the way up to 38. And this is the total of all those numbers. Okay, now our second example. So this one's a little bit different. We're given less information this time for part B. So we have A equal to negative 4, and we have D equal to negative 3. So this sequence would look like this. Negative 4, and then the common difference is negative 3, so it needs to decrease by 3 basically. So negative 7, then negative 10, and this would continue on for 10 terms. Okay, so we also know that n equals 10. All right, so I can't use this formula here because I don't know that last term in the series. I don't know t of n, the last term. So luckily we have this formula here, and where all I need to know is the number of terms, n, which is there and there. And I need a and d. A is here and d is there. So we're good to go. We have everything we need to use that second formula. So S of n equals n over 2, 2a plus d times n minus 1. So there's 10 terms. The first term was negative 4. The common difference is negative 3. And we have 10 minus 1. So that's going to be 5 times negative 8. And then we have negative 3 times 9, which is negative 27. So that's 5 times negative 35, which is negative 175. So really, a lot of these examples in the homework is just going to be using these formulas that you're given. Okay, so you got to look at the information that you have and see what it relates to. Okay, that's it for our first video. I'll see you in the next lesson.